Hello everyone. In this video we will be going through the basics of Numpy. We will first import Numpy as np. Now what will this do is, instead of typing numpy.numpy.numpy. Every time, we only have to type np dot. First of all, we will create arrays. If you are coming from a compiled language background, C++, Java, you already know what arrays are. But in Python, there was no default support for arrays. Arrays are matrices. Now NumPy bridges that gap. First of all, we will create an array. We will use the array function np.array, and to create an array from a set of elements, we will pass those elements as a list to the array function. 1, 2, 3. Let's see what do we have in array. As you can see, ARR variable, it contains array, and this is a one-dimensional array. As you can see, one row, this is a one-dimensional array. What if we, in general, we use at least 2D array or 3D array? Images are 3D arrays. Images are three-dimensional matrices because images contain red matrix, green matrix, blue matrix. That's why it is a three-dimensional array. Let's create a two-dimensional array. ARR is equal to np.array. Now, instead of providing a single list, we will provide a list of lists. That is, this is the parent list, and then we will provide the list, that is, we will pass the list as elements per row. Suppose we want to have a two-dimensional array, that is a matrix with 2 rows and 3 columns. How do we do that? 1, 2, 3. We will pass a list with 3 elements. Then again we will pass another list with 3 elements. 4, 5, 6. What do we have in ARR array? As you can see, we have an array. NumPy has created an array for us with 2 rows and 3 columns. 1, 2, 3. So now, how do we, let me recap this. In order to create an n-dimensional array, we will pass different rows and columns in separate lists. Okay, this was very simple. Now let's create a matrix of only zeros. How do we do this? We will again use an inbuilt function np.zeros. Zeros and ones. Zeros will populate all the elements as zeros. Ones will populate all the elements as ones. Suppose we want to have an array of 3 elements with 0 as value. np.0 has done that for us. Now what if we want to have a two-dimensional array with 3 rows and 4 columns with 1 as value? We will again use the np.ones function and 3 rows and 4 columns. By the way, I'm using Google Colab. You can use Jupyter or Terminal, anything you like that, anything that you are comfortable with. As you can see, there are 1, 2, 3, 3 rows, 1, 2, 3, or 4 columns. Now, how do we check the dimension of an array? We will use the n-dimension function. Actually, this is not a function, this is a variable. Because we are not calling any function, we are simply checking the value. Okay. And how do we check the total number of elements in an array? We can use the size function. We can check the value in the size variable. Okay. And what if we want to check the shape? Again, we can use a shape. So how do we distinguish between a method, function, or method, that is function, or a variable? If it is a variable, we will simply type the variable name, and if it is a function, we will call the function like this, or pass some values, pass some arguments. That end time of, suppose 1, we will get an error, but yeah, this should not work. array.name. And what do we have here? What if you want to generate evenly spaced numbers between a range? For example, np range. We want to generate an equidistant range between two numbers. That is, suppose 0 to 10. np.a range 0 to 10. Here 0 is inclusive but 10 is not. And we want to generate a range, a series, that is arithmetic progression AP, with 2 as the difference. That is, we want to generate a range from 0 to 10 that has a difference of 2. Remember that 10 is exclusive, 0 is inclusive. 0 is inclusive, 10 is exclusive. np range. As you can see, because 0 was inclusive and 10 was exclusive, 10 is not included. And there are 5 numbers, 1, 2, 3, 4, 5. And the difference is 2. And the difference is uniform. This is an AP. Now, what if we want to generate an array with a specified number of evenly spaced values? That is, suppose we want to generate 5 values. We want to generate 5 values between two numbers, and these are definitely equidistant. How do we do that? We will use the line space function. Line space array is equal to np.line space. Oh, there is no underscore. Now 0, 1 and 5. Now here, as you can see, both 0 and 1 are inclusive here. And what do we have in this array? As you can see, np.linspace, that is line space function, has generated 5 values for us, and these are evenly spaced between two numbers, 0 and 1. In this case, 0 and 1 both are inclusive. In case of a range, that is a range, you can say this a range, it does not matter. Only first number, that is the initial number, is inclusive. Second number is exclusive. That is end number of the range is exclusive. In line space, both starting number and ending number are inclusive. And that's it for this video. This was a quick introduction. I will be uploading a next video in a few days, which will be the part 2, and it will contain some more complex functions and complex use cases. Thank you for watching and subscribe for more.